Cool. Sandra, you can now proceed. Thank you.
Okay, so welcome everyone. I hope we're all ready to learn and engage. So this afternoon, Team Air will be taking you through the rest of the content. We'll be clearing up on the database module. And so for the first session, Fan will be taking us through the first session. So get ready to learn and have fun with Fan. Karibu sana Fan, you can take it away.
Hi guys, I hope you can hear me.
Yes, you can.
All right, a minute, I'll just share my screen. Can you see my screen?
Yes, we can on migration.
Yeah.
Yeah.
Okay, so I'm going to take you through AWS Database Migration Service and briefly on AWS Aurora. So AWS DMS in short is a managed cloud service that you can use to migrate databases, data warehouses, NoSQL databases, and other data stores. It can be to or from AWS or between cloud and on-premise setups. So AWS DMS supports both homogeneous migrations, that is same engine to same engine. That is, for example, if you want to, let's say, migrate data from Oracle to Oracle, and it also supports heterogeneous migrations, that's different engine types. That's, for example, you want to migrate from MySQL to Aurora. And it also does AWS migration. It also supports, let's say, on-premise to AWS cloud. But AWS DMS does not support, let's say, on-premise to on-premise. It does not support that. So it also, for AWS DMS, there's also something called CDC, which is a change data capture. So CDC replicates ongoing changes as you're migrating data from the source database to the target database. This is so that there's minimal downtime while the migration is occurring. So we are going to go through the DMS architecture. Can you see the diagram?
Yes, we can.
Yes, we can. Fun.
Yeah.
Just close this sidebar so that you can see your entire page.
Which sidebar?
On the left, there's this arrow showing you going to the left, like it wants to go home. That one.
That one.
Yes.
That one.
Awesome. Perfect. Yes.
Right. Okay, so this is the DMS architecture, and you can see there's a source database and the source database. So the source database, this is the origin of the data to be migrated. That is where your data is currently residing. It can be on-premise, on a database on an EC2 instance or another cloud. And at the other end, there's also a target database. This is the destination. That is where you want to migrate your data to, your database to. So it is the database destination that you must provision before migration. Now in the diagram, you can see a replication instance. So a replication instance, it acts as the migration engine during the migration process. So it does all the ETL for data engineers, extracting, transformation, and loading from the source to the targets. And endpoints, the source endpoint, the target endpoints, these are the connection definitions for both source and targets, in which when you're doing the migration for cloud, you set the host, credentials, and all other connection details. So the endpoints connect, the source endpoint connects the source database, and the target endpoints, it's like your endpoint to your target database. So there's replication tasks. This is a feature. It defines what data to move, how to transform, and the migration mode. So here you can see the migration mode. There's full migration, there's CDC. So for full migration, a minute, sorry. Okay, so for full migration, this is you migrate data from a source to a target database, and it's like a one-time data migration, a full load. And then there's a CDC. So CDC, it captures changes to a source database occurring. You see, let's say when you're transforming data and you want to transform, when you start the data migration process, there's that load. Now, when the transformation is going on, the system is still online, so there are other changes occurring in the background. So CDC does that. It captures those changes, inserts, updates, deletes that are occurring during migration, and does those changes to the target database until they become synchronous, both the target database and the source database. And there is monitoring and logging, in which Amazon CloudWatch and the DMS, also the console, provide metrics, alerts, and logs that track the migration process and troubleshoots issues. So this is how it works. You launch a replication instance to act as the engine, and then you configure your source and target endpoints with necessary connection. Remember up here we've said endpoints, they must be provisioned. The target database and the endpoint, they must be provisioned. Where is your data going to? So you create a replication task that defines the data to be migrated and whether you need a CDC ongoing replication is required. So the system does the initial data load, and then after when the initial data load begins, it then uses CDC to capture and apply changes from the source until cutover. That is, cutover is when, I'm sorry about the background noise, kids are playing. So the cutover is when the source database and the target database will become synchronous, in that they'll be the same. And then throughout migration, you monitor via log and metrics until completion is achieved with minimal downtime. So for the benefits of AWS DMS, there is minimal downtime thanks to the change data capture and continuous replication. Flexibility, it works for various sources and both homogeneous and heterogeneous migrations. You remember we said you can migrate from this one data engine to a different one, or one data engine to the same data engine, and it's fully managed. And sorry, AWS handles much of the heavy infrastructure work, and you don't have to do all that. And it's secure, so it supports encryption during transit of the data, and the data at rest in S3. Okay, so that's it with Amazon DMS. There's much more about it. If you want to learn a lot of it, you can go to AWS documentation on their website. It even guides you on the heterogeneous, all sorts of migrations. So we are going to Amazon Aurora. The group that was leading in the morning touched a bit on this, and I'm also going to pass by it briefly. So Aurora is a relational database engine that's provisioned by AWS that combines the speed and reliability. Remember Joyce said, so its features, Joyce said it's 5 times faster than MySQL, and it's 3 times faster than Postgres. So it's compatible. Amazon Aurora works with MySQL and Postgres. So applications that support those engines can run with little or no changes and high availability. The AWS replicates data across multiple AZs with automatic failover. Durability, 6-way replication of data across 3 availability zones. And there's also security in that the data is encrypted at rest and while it is in transit, integration with IAM policies and VPC isolation. So there is the Aurora DB cluster. A DB cluster, an Aurora DB cluster is the fundamental architecture that manages how Aurora stores data and handles connections. So an Aurora DB cluster, it consists of a cluster volume, which is a distributed storage system that's replicated across different availability zones. And the cluster volume scales up to 128 TB without manual intervention. So this cluster volume is shared by all instances in the cluster. Remember, the Aurora DB cluster has more than one instance, and all those instances, they share these one cluster volumes, and this eliminates replication lag. So there's also the primary instance. This primary instance, it handles read and write operations in that you can update, you can retrieve all those operations. And if it fails, Aurora automatically promotes one of the replica instances to be the new primary instance in case of a failure of the primary instance. Now the Aurora replicas, I remember in the morning they said a DB cluster consists of 1 primary instance and up to 15 read replica, Aurora replicas. So the Aurora replica is read only, it does not support write, and it uses the same cluster volume and fast. So since it's read only, you find that it supports consistency and fast of apps that are in the DB cluster. And it can be promoted to the primary instance if a failure occurs. So there is also endpoints, and a cluster endpoints. This one directs traffic to the primary instance for writes. Reader endpoint, it loads balance connections across replicas for read scaling. And custom endpoints, it routes traffic to specific subsets of the DB instances. So in short, the Aurora DB cluster, it's a managed, highly available database environment where multiple instances share, where multiple instances share a single resilient storage layer, that is the cluster volume. And remember, we say the cluster volume is in all availability zones. So Amazon Aurora use cases, it's a good thing I'm not seeing the Zoom because I know you guys are laughing. Anyway, Amazon Aurora use cases, there's high performance web and mobile applications. So Aurora is ideal for apps that need low latency and high throughput. We say that throughput is rate of data transfer, such as e-commerce platforms, and social media. Social media has people logging in, millions of users, and others are pulling content at the same time. So it has to be, the availability has to be good. So Amazon Aurora that's one of the use cases. Then there's software as a service applications. SAS platforms have many users and unpredictable workloads. And the architecture of Amazon Aurora, we've said Aurora DB clusters support up to 15 read replicas, make auto-scaling perfect for handling different users. Since read commands, let's say read commands are load balanced among the Aurora replicas, it supports very little, no downtime and all performance drops of the applications. Then there's enterprise applications. So businesses migrating from expensive on-premise databases can use Aurora for great performance at a lower cost with built-in high availability and automatic failover. And there's also analytic and reporting systems. The Aurora supports read replicas for analytic queries while keeping the primary database focused on transactions. Again, the primary database supports read and write, and the replicas support read only. So the replicas handle the read operations. So this allows real-time reporting without slowing down the main app. And there's gaming and real-time applications. So Aurora's replication and low latency make it suitable for online gaming, in which you find 1 million users are playing games at the same time. And IoT applications, remember IoT have to stream data in real time. So Amazon Aurora enables the data consistency. Yeah, and that's my short presentation.
All right. Thank you, Fan. Leonard says he's a fan. So Makofi, if you have any questions, who's that not clapping? I've not seen John Wick clapping. Okay, I've seen. Sorry. So, if you have any questions, you can send them in the group, or if you have a challenge, you can send them in the group. But thank you, Fan, for the presentation. You've done a lovely job. Next up, we'll be having Frank. Yeah, we're the only team with a foreign member. We're just saying. But welcome, Frank. You can share your screen and present.
Okay. Can you guys hear me? Can
Yes, we
everyone hear
can.
me?
Yes.
Okay. So, before I go into my presentation, I mean, good job, Fan. Before I take over from
Thank you, Frank.
my partner, Fan. Wait, I mean my topic partner, Fan. Yeah, no room for conspiracy theories. Okay, so as a new member of the Kenyan community, I have a question. Before I go into my presentation, I have a question and I need some answers. So I've shared an image in the chat. So I want to know the story.
That's a lawyer guy.
Please, have you guys received my message? I want to know the answers to that question. Seeing as I'm a new member.
Ugali is our staple, Frank. Ugali is our staple, and it has to be introduced properly. Have you seen that size?
Yes.
What Fred normally does, he's one of the farmers in our country, an influencer of sorts also. So what he does, he posts these pictures maybe on a daily, and you see that big ugali. Maybe sometimes it's big ugali with kales, sometimes it's big ugali, like in that case, you can see it's big ugali with some chicken. And now someone is saying that one day we need to explain what is our beef, what is our problem with soup. No, he's
I'm
not
very
unwell.
interested in the meat.
No, he's not unwell. He's not unwell. You know, content creation is just content creation. But he's one very good farmer. He's one very good farmer. Yeah.
Oh, okay.
Mm.
Okay, so that was just by the way. Thanks, Patrick. Okay, so can everyone see my screen? I'm sharing my screen. Amazon DynamoDB. Okay, so Amazon DynamoDB, what is it and why should we be concerned as AWS learners? But just before we go into that, I think we have to do a comparison of relational and non-relational that is NoSQL databases. You have to do a comparison of that. But wait, let me hide this first because Team Fire has already done a great job on databases. So before I go into my presentation, I'm going to ask some questions to verify if we actually learned what Team Fire did before I go into it. And also, I should add that in my government, there's limited democracy, so I'm going to mention names. So, okay, so guys, what's a relational database? Let me hide this first. I especially need answers from the Friday team. They are too relaxed for my liking. Which guys are presenting on Friday? Daniel, you are presenting on Friday, right? What's a relational database? Is he in class? Justin, so you see, I thought TFI had done justice to it, but apparently some people can't even remember. Okay, Thursday team. Who are they? Who are the Thursday members? What's a non-relational database? No one is talking? Okay, well, let me just open the participants and let me mention people's names. Let's see if you can hide. Okay, so I see some.
Clinton says a non-relational is an unstructured database.
Okay, that's good. More points for Clinton. And okay, Gideon said has tables and columns for the relational database, so also more points for them. Daniel did not say anything, so let's deduct points from him and give it to Gideon and Clinton. Okay, so I'm just going to dive into it. Amazon DynamoDB, Database Fundamentals, Introduction to DynamoDB. So one, relational and non-relational NoSQL databases, a comparison. Relational databases, also known as SQL databases. Data is stored in tables by using predefined columns of specific data types. Relationships can be defined between tables by using table foreign keys. Better performance is achieved by adding compute or memory capacity to a single database server. Relational databases are used to store data for a wide variety of applications. Relational databases use normalized database table designs, which means that data is stored across multiple tables with defined relationships between the tables. The data stored in a relational database table must match the design of that table. Every record layout is essentially the same, only the data is different. So here we can see a table which mimics what a relational database is. You see that we have an ID, we have name, we have age and email. And each column is filled. Like we have ID 1, John, age 25, email, john@email.com, and the same goes for Mary as well. An example use cases of a relational database is in the banking systems where every customer must have the same info as account number, balance, transactions. E-commerce, yeah.
Could you expand or enlarge your screen, please?
Oh, okay. 1 second.
Alternatively,
okay?
just make the font bigger. Yeah, or zoom. Yeah, I think that is better, right?
Yeah, that's okay.
Cool.
Okay, so like I was saying, You see, in the banking systems, every customer must have the same info, like account number, balance, transactions. In e-commerce store, we have products, orders, and customers all fit neatly into tables, as well as a university system. Students, courses, and grades, they all have clear relationships because relational databases follow a strict structure. Everything must be the same thing. So when we go down, you see why SQL works here. It says you need accurate relationships in data consistency, i.e. no duplicates, no missing info. And examples of SQL databases are MySQL, Postgres, Oracle, SQL Server. So most relational databases run on a single large database server with a fixed amount of memory and compute capacity. If better performance is needed, a bigger server with more memory or compute capacity is used to replace the existing server. Okay, so, and then we move to non-relational NoSQL databases. With NoSQL databases, data is stored in tables with a flexible column structure. Each item stored in a table can have a different number and type of data elements. Better performance is achieved by adding a new server to an existing pool of database servers. Non-relational or NoSQL databases are more flexible in the way that they store data. So we have document databases like MongoDB, which stores data as documents, usually in a JSON format, similar to how you'd store files with key value pairs. And we have key value stores like Redis, which stores data as a simple pair of key and value, like a big dictionary. Then we also have column family stores like Cassandra, which stores data in columns instead of rows, which is great for large-scale analytics. Then we have graph databases like Neo4j, which stores data as nodes and relationships, perfect for social networks or connections. So it says data for one record in a database can be of a different layout type and the size from data for another record in a database. And if we scroll down, this image is the JSON format of how illustration of how a NoSQL database is like. So you see, we have John, name John, age 25, email, john@gmail.com. But with Mary, we have name, age, email, and then address, which is perfectly fine for a NoSQL database. Unlike the SQL database, which enforces a strict system and everybody must have the exact same thing. You see, this is a SQL database, but down here we have the NoSQL one, which is much flexible and allows for a varying attributes. Okay, so an example use cases of the NoSQL database is a social media app. Every post can have different fields, photos, videos, tags, reactions, IoT or sensor data. The devices send different kinds of readings at different times. Okay, so you can't enforce structure on that. And then we have real-time analytics or logs. You just keep storing events as they happen. So it's fast and varied. So why NoSQL works here? You need speed, scalability, and flexibility, not a strict structure. And then examples of NoSQL databases are MongoDB, Firebase, Cassandra, Redis, and Neo4j. NoSQL databases run on a group of servers called a cluster, each with its own fixed amount of memory and compute capacity. If better performance is needed, additional servers can be added to the existing cluster group. To put it simply, SQL, that is relational databases, follows a strict, well-organized cabinet, which is great for stable, structured data. NoSQL or non-relational databases are like flexible computer folders, great for fast-changing or unstructured data. On a lighter note, if you're a football fan, you can just compare SQL database to Cristiano Ronaldo. You know, it has a strict system. You know what to expect from him. He's good for Champions League. And the NoSQL database, you have Messi, who can adapt to anything and can give you a World Cup. That's his scalability, you know. No offense to Ronaldo fans, but you know it's true. If you're a non-football fan, you can compare SQL databases to a man. See, men are simple creatures. They don't lie. We don't lie. We mean what we say and everything. But no SQL ones are like the other gender. They don't know what they want. Yeah, they don't know what they want. And
I
they're
wonder
looking.
why the ladies are quiet. Eh, ladies.
Because they're not sure about the answer.
Ay,
Actually,
ay, ay, ay. We have agreed with Ronaldo being sequel, yes, but women, no, we refuse violence.
Okay, so you see, even Aurora, the name sounds cool and simple like a man, but look at DynamoDB, the name sounds wicked, just like the hearts of women. They're very wicked too. Men. So if you see DynamoDB, you know it's women we are talking about. Anyway, so moving on, DynamoDB is a NoSQL database. So you look at this illustration, you see a NoSQL database has fast performance, high availability, high scalability, big data capability, and easy replication. Which is why they are more suitable for social media, because you keep receiving data on the fly. So what is DynamoDB? A fully managed serverless key-value NoSQL database that does the following: improves performance by keeping data in memory, keeps data secure by encrypting data at rest, protects data with backups and automated copying of data between AWS regions. DynamoDB offers the following advantages: a fully managed service, i.e. AWS manages all of the underlying compute and storage needed to store your data. Scalability. DynamoDB automatically adds more compute and storage capacity as your data grows. Redundancy. DynamoDB copies your data across multiple AWS regions to avoid data loss. Recoverability. DynamoDB can restore your data from automatic backup operations. Low latency. Data can be read from DynamoDB table in a few milliseconds. Security. You can use DynamoDB with AWS Identity and Access Management, IAM, to control access to DynamoDB tables. Flexibility. DynamoDB can store several types of data, and each record can have varying numbers and types of data. JSON is one popular way to store data in DynamoDB, which I showed you guys above. So are we cool? Guys, are you following? Is everything okay? Okay, so how does it work? So in this image, we see the DynamoDB table hierarchy. So you see a DynamoDB table and an item, and then it has attributes. And then a second item, which also has its own attributes. So basically, this is how the DynamoDB table hierarchy is. So key concepts: tables, i.e. the core concept behind DynamoDB. Tables in DynamoDB, similar to relational database systems, DynamoDB stores data in tables. The table name and primary key must be specified at table creation. We are going to see this when we do the lab. Each DynamoDB table has at least one column that acts as the primary key. The primary key is the only data that is required when storing a row in a DynamoDB table. Any other data is optional. Guys, please remember this point. The primary key is the only data that is required when storing a row in a DynamoDB table. Any other data is optional. So example, suppose you want to create a DynamoDB table to store data about your friends. The friends table can do the following. 1, use an ID number to identify each friend. 2, use this ID number as the table's primary key. Each DynamoDB table must have a primary key, and each row in a DynamoDB table must have a distinct value for the primary key. So here we see a table. illustration of friends in the DynamoDB table. So we have friend ID, we have all this, and then we have the names, we have age. You see that Dana has nothing here. And then favorite color, Alice has blue, Ben has none, Clara has green. There's none here, which is also fine with NoSQL or non-relational databases. We have hobby and all that. So here, each item can have different attributes. Ben has a hobby, but no favorite color. Diana has a hobby, but no age. And that's totally fine in DynamoDB. It's flexible. You can store whatever data each record happens to have. Okay, so moving on to attributes. So a column in a DynamoDB table is called an attribute. An attribute represents a fundamental data element, something that does not need to be broken down any further. Any attribute is similar in concept to table columns. An attribute is similar in concept to table columns or fields in a relational database, and a primary key can consist of one or two attributes. So if you scroll up here, if you come up here, you can see the attributes, the illustration, DynamoDB table, item. These are the attributes. And the same thing for this one as well. Okay, so an example, the friends table uses the friend ID attribute for the primary key, but other attributes might include the following: name, hobbies, favorite colors. So this, while this one can be used, the friend ID here can be used as the primary key. These are other attributes in the Dynamo database table. Okay, so items. An item is a group of attributes that is uniquely identifiable among all other items. Each item consists of one or more attributes. Each item is uniquely identified by its primary key attribute. This concept is similar to a table row in a relational database. And the difference is the number and type of non-primary key attributes can be different for each item in a table. An example, data for each friend is stored as an item. Each friend has an ID plus any other attributes that you want to store about that person. The amount and type of data stored for each attribute can vary for each friend, which we saw here. So item 1 is Alice. These are the attributes. Okay, so relational databases use tables made up of columns to store data as rows. On the other hand, DynamoDB uses tables made up of attributes to store data as items. Each item stored in a DynamoDB table does not need to have the same number or type of attributes. This property is the difference between NoSQL tables and relational database tables. With relational tables, the number and type of data in each row must match the table's structure. Must is highlighted. Must be highlighted. Must match the table structure. Okay, so moving on to primary keys. Simple primary key. The primary key consists of one attribute. The attribute is called a partition key or hash key. A primary key that is based on a single table attribute is called a simple primary key. The attribute that the primary key is based on is called a partition key or hash key. Like a single unique ID. Example, friend 101. See, so this ID is unique to friend ID. So if maybe let's say Alice has friend ID 101. It is unique to her alone. Okay, so we have, and then we have composite primary key. The primary key consists of two attributes. The first attribute is the partition key or hash key. The second attribute is the sort key or range attribute. A primary key that is based on two table attributes is called a composite primary key. The first attribute in a composite primary key is called the partition key or hash key. The second attribute in the composite primary key is called the sort key or range attribute. And this is like identifying a student by their classroom and their seat number. Or like the groups we have on WhatsApp, like if you're, let's say for instance, you're trying to identify fun. So you can identify them by let's say by her team, which is team A, and maybe we are sorted into initials. We are sorted by initials. So team A, and then FM, Fan Messiani. So when you look at the use cases here, it says composite primary key, querying groups of related items with sorting and filtering capabilities. So when you want to do something like get from team A, where initial is equal to FM, then you know that we are talking about Fan Messiani over there. But assuming we had unique IDs and Fan had maybe 101, you can just say get from team A, or you can say get ID 101, and then you get Fan directly. So we also see this during the lab. So the concept of partitioning. Partitions. DynamoDB tables store item data in partitions. Table data is partitioned and indexed by the primary key. Each table has one or more partitions. New partitions are added as data is added to the table. Tables whose data is distributed evenly across multiple partitions generally deliver the best performance. The partition in which an item's data is stored is determined by its primary key attribute. The value for the friend attribute will determine which partition in the friends table will store the data for that person. And then we see the image here where the friends table is split into partitions. So we have partition 1, partition 2. Which is just like how Inspector Joy grouped us into team A, team at team 5 and all that. So maybe we have IDs, and then she decided to group us using the ID. So she says, Fan, Frank, Daniel, Sandra, you go into team A, and then the others goes into the other team. So that is how the partition works. And then, so DynamoDB table store data in partitions. Each table comprises one or more partitions. DynamoDB automatically adds new partitions to a table when the existing partitions fill with data. Okay. We'll talk about this some more, but let's look at this one. Storing items in partitions. This example shows the item data for Martha Rivera being stored in the friends table. When choosing the partition to store the data, DynamoDB applies a function to the partition key attribute of the primary key. In the case of the friends table, the primary key is a simple primary key. Therefore, the partition key attribute is the same as the primary key, which is friend ID. The value that the function returns will be in either partition 1 or partition 2, depending on the value for the friend ID. In this case, the function chose partition 1 to store Martha's data. So let's assume the function. So you see here, it says the DynamoDB applies a function to the partition key attribute, which it uses to determine which partition to store the data. So let's assume the function says if the friend's ID number is odd, put it on shelf 1. If it's even, put it on shelf 2. So we see here, Martha, friend ID 1, function says go to partition 1. For Jan, friend ID is 2, so function says goes to partition 2 because 2 is an even number. So you can see it here. Let me enlarge this one a bit. And it does it so well that data is evenly distributed. Again, I'm going to use the strategy again. So let's say when she decided to group us into these groups, team A, team 5, team Ether, team, all that, she had her own function, which may be prophetic vision or theology. Maybe she had a dream and then decided to put Daniel and Sandra in the same group, which is very prophetic because it was just perfect, you see. Yeah, so that's how it works. So the prophetic vision is the function she applied on her on her name list, and then decided to put Sandra and Daniel in the same group. So that's how the DynamoDB works when it partitions the data, and it makes it does it so well that the data is evenly distributed, and then it is able to retrieve data using the same way. So storing attributes in partitions. So this is the image. This example shows the item data for another friend, Jiang Wei, which is being stored in the friends table. When choosing the partition to store the data, DynamoDB applies a function to the partition key attribute friend ID. In this case, the function chooses partition 2 to store Jiang's data. Notice that 2 additional attributes are being stored for Jiang, more than were stored for Martha. These extra attributes do not present a problem. If an item has a primary key value, DynamoDB permits each item to have different numbers and types of attributes. So in the image, you can see friend 1, which is Martha, has hobbies, favorite colors, and that's that. But for Jiang has hobbies, favorite colors, favorite games, favorite foods. And then he goes into partition 2. So again, you see that it is not a fixed something like a SQL database, relational database thingy. NoSQL ones are flexible and can store as many as much as possible. So DynamoDB global tables. Core concept for global tables. Using the global table option creates a DynamoDB table that is automatically replicated across your choice of AWS regions worldwide. It delivers fast, local read and write performance for global applications. Your applications can stay highly available in the unlikely event of isolation or degradation of an entire AWS region. Global tables eliminate the difficult work of replicating data between regions and resolving update conflicts between copies. Example, so let's say you have 1 million friends all over the world who use your friend table. Global tables will put the table data closer to your friends. You understand? So let's say maybe Facebook, right? And then you have friends. So the data, your data is replicated by DynamoDB in all of those regions. And in this way, being closer to data means that your friends will experience faster query performance. You see, so if your friend logs in and you update your data, because the data has been replicated worldwide, and if the person is in Brazil, they get it instantly. But if global tables are not worldwide, are not replicated worldwide, then they will have to wait. You understand? So the DynamoDB global tables feature provides high availability and scalability across regions. The global table is a collection of one or more DynamoDB tables, which must all be owned by a single AWS account. The tables in the collection are also known as replica tables. Each replica stores the same set of data items. When you create a global table, you specify the AWS regions where you want the table to be available. So DynamoDB performs all the necessary tasks to create identical tables in these regions. It automatically performs ongoing copying of data of all the tables to keep their contents in sync. You see, so it's live. DynamoDB global tables works well for large-scale applications with globally dispersed users by accessing the replica that is closest to them. And here is the image. So you see, why don't they have one for Africa? So you see, globally dispersed users, this is the application, let's say Facebook or something. And this is the friends global table. So a replica has been made here, another replica has been made there, and here. So if you're here, you get, you access the data instantly, you see. And the other one here also gets it as well. So you get it at the same time because the data has been replicated. This example shows how globally dispersed friends benefit from DynamoDB global tables by using a mobile application. Users can access the table replica that is geographically closest to them. This access enhances your friend's experience by providing better response times when reading and writing the Dynamo Friends table. In simple terms, DynamoDB global tables are like having your data in multiple countries at once, always up to date, fast to access, and safe from outages. So yeah, I think that will be that. Please don't clap yet. You are going to answer the checkpoint questions I have not forgotten. Okay, so these are the checkpoint questions. And again, those who are presenting on Thursday and Friday, be prepared. You guys are too relaxed. Team Fire is rested now. They've already gone through their fire, and Team Brave. But for Thursday and Friday, people, and I'm going to spare Wednesday people, but Thursday and Friday. Okay, so checkpoint questions. Why are non-relational, non-SQL databases a good choice when you must get started quickly on a project? Anybody from Thursday and Friday?
Pardon the question.
Why are non-relational databases a good choice when you must get started quickly on a project? Well, let me see if there are answers in the chat before I start calling names. Okay, so scalable. Gideon, okay, Gideon, you're part of Friday team. Leonard, are you going to answer the question? Okay, which table at? Okay, I'm going to answer that because Team Friday and Team Thursday, they are hiding. They don't want to talk. Okay, so NoSQL databases have flexible schemas, so it is not necessary to do any data engineering. Developers can quickly and easily work with the data without needing to understand relationships between data. 2, which table attribute is responsible for determining where item data is partitioned? Guys, it's right there. I know you can see it. The partition key is responsible for where the data is partitioned. When you create items in a DynamoDB table, does each entry need to have the same attributes? No, because DynamoDB is a NoSQL database. Individual items can have different attributes from other entries. Okay, so to summarize this, these are the key takeaways. So this module includes the following key takeaways. DynamoDB is a fully managed NoSQL database service. DynamoDB offers consistent single-digit millisecond latency at any scale. DynamoDB has essentially no table size or throughput limits, and global tables reduce the difficulty of replicating data between regions and resolving update conflicts.
Hi,
Okay,
Frank. Sorry.
Okay.
Whatever you are reading, we can't see it on your screen. Are you reading from a different screen, or is your screen frozen?
Oh, I think it's the sharing.
Okay, please just
Okay.
you can reshare.
Oh, let me check it. Okay, so this is what I was reading.
Okay, cool. We can see it.
Yeah, you can consult your notes. Please, are there any questions or any contribution or inputs before we go to the lab? No question?
Frank, before you finish, I'd like to ask the people, you guys, because you did not answer the checkpoint questions, I have a question. So imagine that we are an example of our e-commerce site, right? And we are here in Kenya. Say, okay, not our e-commerce site. Say we have developed a social media application. We've developed our own Instagram, right? And we are here in Kenya, all right? And, oh, no. We are in Ghana. Let's say we were invited to Ghana to create our Instagram, all right? Now, because we are in Ghana, our social media site is gaining traction, and people in Korea, people in Canada, people in South America, Chile, people in Kazakhstan, all those people are interested in our site. Okay. But what can we do so that they can all be able to send their pictures on our application, that is, upload their photos in our application, they can get to see themselves, they can share information, because we are using DynamoDB. What can we do so that our application can be easily accessible to them, where they can store and retrieve their data easily? What can we use in DynamoDB? Frank, don't answer for them.
Okay.
Let me see if you guys are following up. A scenario question. We've created our social media application and it's gaining traction all over the world globally. And we are using DynamoDB. What can we do for users to be able to retrieve and access data and upload the data to our social media application easily and fast? What can we use in DynamoDB? Exactly, Sandra. Sandra umewasaidia. Exactly. We are going to use the DynamoDB global tables. It's okay. So guys, kindly follow up. This, it will definitely come to your exam. All right, Frank, kindly continue.
Okay. Thanks, Joy. Okay, so we'll be doing the lab. So kindly open your labs and start it. Let me share my screen. Let me share my entire screen. Hmm. Well, wait, where did the share entire screen disappear to? Because I can't find it.
Are you using your Zoom for application? The Zoom application?
Yeah.
The Zoom. Oh, that's why. That's why. Kindly just log into this meeting using your web. That's when you'll be able to share your entire screen.
Okay. Okay.
All right, sorry.
Uh, hmm.
We can give you a minute or two as you do that, and also tell us
Okay.
the number of lab that we need to open.
Okay. I think it's the one on DynamoDB, which is 275.
All right, guys, open lab number 275. Everyone kindly open lab number 275. Belinda, how are you? You love laughing.
I'm fine. I've laughed entirely through Frank's presentation.
Oh, same here, same here. Gail, I'm going to tell Frank that you guys are very relaxed presenting on Monday. Kindly, guys, open your lab number 2. Open lab number 275. But have you learnt about it now, Gideon?
And Joy, just a heads up to all the learners. As you go through databases, one of the things that you need to be very, very keen on are the use cases. The use cases, like you'll be given a trick question, or you'll be given a question and then you'll be given choices there. So you need to know which DB is appropriate for which use case. So pay very, very close attention to that. And actually DynamoDB and RDS feature a lot. They feature a lot. So pay attention. Cool.
Thank you for that, Patrick. I really appreciate for that. Yes. You guys, right now we are kind of preparing you for your exam, okay? Gideon, a question for you, Basi. A company is planning to migrate to AWS to save its cost, and it is currently using an SQL database. What equivalent of it can it use on the AWS, and what can it use to migrate its data? What service can we use to migrate our data, and what NoSQL service can it use? All right, very nice. They can use DMS to migrate. And what non-relational database can they use when they come to AWS? Were you people in class? Gideon, what AWS exactly? Exactly, good. Continue, Frank. Thank you for joining us. Continue.
Well, hello, guys.
Hi, Frank.
Please, can you all see my screen?
Yes, we can.
Yeah, both the lab and then the console home,
Yeah.
right?
Yeah.
Okay, and I assume all of you have opened to this lab. Are we all here? Lab 275.
They are saying that
Okay.
they're
Okay, then I'm gonna proceed. Okay, so introduction to Amazon DynamoDB lab overview. Amazon DynamoDB is a fast and flexible NoSQL database service for applications that need consistent single-digit millisecond latency at any scale. It is a fully managed database and supports both document and key value data models. Its flexible data model and reliable performance make it a great fit for mobile, web, gaming, ad tech, IoT, and many other applications. In this lab, you will create a table in DynamoDB to store information about the music library, you will query the music library and then delete the DynamoDB table. Okay, so these are the topics. So you create a table, you will enter data into the table, we will query the table and then delete the table. So I'm just gonna go to task 1. Okay, so in this task, you create a new table called music in DynamoDB. Each table requires a partition key or a primary key that is used to partition data across DynamoDB servers. A table can also have a sort key. The combination of a partition key and a sort key uniquely identifies each item in a DynamoDB table. So in the console, the instruction is to choose services menu, which is here. Guys, are you following? If I'm going too fast, you just alert me. So this is the services menu. And the database, choose DynamoDB. So this is database. And then we have DynamoDB here. So while we wait for it to load, wait, why is this taking so long? Oh, wait. Let me see. Let me first separate the views. Okay. Okay, this is taking a while. Okay. Okay, so task 1 says we open the services, we open DynamoDB from the services menu, and then we create table. So the button is right here. We click on this to create a table. For table name, enter music. So we type in music here. Oh, okay. And then for partition key, enter artist and leave the string selected in a drop-down list. So this is the drop-down list. We're going to leave the string selected. For sort key, enter song and leave string selected. So we're going to enter song and leave string selected. So guys, you notice that for the sort key, it says it's optional. So it's not mandatory as the partition key, which is a must. It must have a partition key. But for the sort key, it is optional. So your table will use the default settings for indexes and provision capacity. So we're just going to use the default settings. So you scroll down and choose create table, which is here. And then we wait. It says the table will be created in less than 1 minute. Wait for the music table to be active. So when you check the status here, you see that it is creating. Okay, so we are going to wait for this to change to active. before we move to the next task. Then it's done, so it's active. Task 2, it says in this task, you add data to the music table. The table is a collection of data on a particular topic. Each table contains multiple items. An item is a group of attributes that is uniquely identifiable among all of the other items. Items in the DynamoDB are similar in many ways to rows in other database systems. In DynamoDB, there is no limit to the number of items you can store in a table. Each item consists of one or more attributes. An attribute is a fundamental data element, something that does not need to be broken down any further. So for example, an item in the music data table contains attributes such as song and artist. Attributes in DynamoDB are similar to columns in other database systems, but each item, i.e. row, can have different attributes, i.e. column. When you write an item to a DynamoDB table, only the partition key and sort key, if used, are required. Other than these fields, the table does not require a schema. This means that you can add attributes to one item that may be different than the attributes for the other items. Okay, so it says choose the music table. So you just click on this one. Then it says you choose actions and then choose create item. So actions is right here. So we click on this one, actions. Then we create the item. For artist value, enter Pink Floyd. For song, enter money. So these are the only required attributes, but you now add additional attributes. Okay, so to create an additional attribute, choose add new attributes, which is right here. So we click this one. In the drop-down list, select string. Click on string. So a new attribute will be added. For the new attribute, enter the following field, album, and the value is Dark Side of the Moon. I'm just gonna copy this. Okay. And then we're going to add another attribute in the drop-down list. You choose number. For the new attribute, enter in the field, you're going to enter year. And then value, 1973. And then we create our item. Okay, so we see over here, one items returned one. So it's over here. Let me just stretch it out a bit. You see, this is the item. Item one has been added. Okay. So similarly, to create a second item, use the following attributes. So we are going to add a second and then a third one. Okay. So let me just squeeze this a bit. Okay. So we're going to create again. I'm going to move fast this time. So artist John Lennon. Song Imagine. Add a new attribute, which is string for album. Going to add Imagine again. We add another attribute, which is a number this time. And the value is 1971. And then the new attribute genre is here, so we add that one too. soft rock. Okay, so this item has an additional attribute called genre. This is an example of each item being capable of having different attributes without having to predefine a table schema. So we create an item. Then the third one, artist, the Gangnam Style guy. Second one, song, which is the sort key, is Gangnam Style. Then we add another attribute, string, which is album. And then the attribute value, we're going to put it here. Okay, then we add a year. 2011. Number, and then length seconds over here. 219. Okay, so we create our item. So you see, once again, this item has a new length seconds attribute identifying the length of the song. This demonstrates the flexibility of a NoSQL database. There are also faster ways to load data into DynamoDB, such as using the command line interface, programmatically loading data, or using one of the free tools available on the internet. Okay, so items have been created. We see 3 of them here in their glory. And then task 3 says modify an existing item. Okay, so you now notice that there's an error in your data. In this task, you will modify an existing item. So in the DynamoDB dashboard, under tables, choose explore items. And then we choose the music button, which is this one. It is already selected. So you choose PSY, change the year from 2011 to 2012. I'm gonna squeeze this a bit. So you can just come here, you see this button, edit, we change this, and then we save. And you see it's updated over here. And that's it, very simple. Very, very simple. Okay, now we go to task 4, which is query the table. So there are 2 ways to query a DynamoDB table, query and scan. Okay, so the query operation finds items based on the primary key and optionally the sort key. It is fully indexed, so it runs very fast. So 29 says expand scan query items and choose query. Okay, so it's over here, it's already expanded. Okay, so we choose query. Choose query here. So fields for artist, i.e. partition key and the sort key are now displayed. Enter the following details. Artist, artist over here, so we enter PSY, and then the sort key, Gangnam Style. Just gonna copy this one and paste it over here. So if I expand this, you can see this. So sort key equal to Gangnam Style. So this is like the visual interface of what you usually see what the other teams were talking about, equal to. So it's like a select from music where artist is equal to this, okay? Or from music, select psi where song is equal to Gangnam Style. So we see equal to Gangnam Style over here. And then we choose run. Where is the run hidden? Okay, here. So here. So you click on run, and then when you scroll downwards, you see it's been selected over here. has been selected. So the song quickly appears in the list. You might need to scroll down to see this result. A query is the most efficient way to retrieve data from a DynamoDB table. Alternatively, you can scan for an item. This option involves looking through every item in the table, so it is less efficient and can take significant time for larger tables. So scroll up and choose Scan, expand filters. Okay, so for attribute name, enter year. Enter year. Type, we choose number. And then for value, 1971. And then we run. Okay, so we see, when you scroll down, what you see over here, John Lennon, 1971 has been displayed. So only the song released in 1971 is displayed. Okay, so task 5, delete table. So we are done. We are done with all the tasks. I assume everyone is done as well. So in the DynamoDB dashboard, under tables, choose update settings. Okay, this one is covered this. Choose update settings. Where is this thing again? Under tables. So you go to tables. You can see update settings here. I mean, we can delete it directly, but let's just follow the guide. So we go here, update settings. Okay. It become a bit more complicated. So choose music table. If it's not already selected, it's already selected. Choose actions, and then choose delete table. So you see it over here. Okay, on the confirmation panel, enter delete and choose delete table. But over here it says type confirm. So we're going to type confirm. And then click. Okay, so our table has been deleted. Okay, refresh, and there's nothing here. Okay, so that will be the end of the lab. I hope everyone was able to follow. I'm just going to submit this. Okay. So that is done, and I'm going to end the lab. Okay. 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 So, guys, were you able to follow? Okay. I don't know if should we do the KC? I don't know if you should do it because I wanted to give it to you guys as homework, but if we agree.
We can do the KC on the exam prep, the one that Jay was talking about.
Oh yeah. Okay. So, okay, what was the number again? Sandra, do you remember the number?
No, but okay, you have to scroll down till you get to the exam prep. I don't think they have numbers. Let me check.
Oh, okay. Wait. Is it on data? Is on databases, right?
Yeah, it's a KC or in databases. After you go past.
Yeah, I've seen it.
Okay.
Yes. Thanks. Thanks, team lead. Okay, so I'm going to share my screen again. Uh, guys, please confirm if you can see my screen.
Yes, we can.
Okay. The chat has disappeared for some reason. Okay, so I'm going to read and then we answer these questions. So you are designing an e-commerce web application that will scale to hundreds of thousands of concurrent users. Which database technology is best suited to hold the session state in this example? A, NoSQL database table using Amazon DB. B, data warehouse using Amazon Redshift. C, Amazon Simple Storage Service. D, relational database using the Amazon Relational Database Service. Okay, so what's the answer?
They're saying
Platform.
the chat.
Well, let me look at
NoSQL database table using Amazon
Sandra.
DynamoDB.
You said
Yes.
you said they're saying.
Option A, NoSQL.
Well,
Yeah.
let me check the chat and see who is saying what. So if I get it wrong, I know who to go after.
Let me read for you. Felix says A, Clinton says A, and Gideon says A.
Okay. Okay, so let's go with A and C. Whoa, it's correct. Okay. Number 2, you need to find an item in an Amazon DynamoDB table using an attribute other than the item's primary key. Which of the following operations should you use? A, post. B, scan. C, get. D, query. Okay, Fan says scan. I trust Fan, so I'm just going to choose what Fan says. Oh, Felix also said B, and Justin says B as well. Okay, so number 3, which AWS cloud service is best suited for online analytic processing? OLAP. So A, Amazon DynamoDB. B, Amazon Relational Database Service. C, Amazon Redshift. And D, Amazon Simple Storage Service Glacier. So, guys, what is the answer? Felix says C. Guys, do you agree with Anthony? Anthony says C. Okay, so let's go with C, but oh, it's correct. For in Amazon DynamoDB, an attribute is A, a fundamental data element, B, an operation on a table, C, a data value, and D, a collection of items. So in Amazon DynamoDB, an attribute is what? Guys, I'm waiting for your answers. Felix has been very active in the chat. Instructors, more points to Felix and also farm. So a fundamental element. That is correct. Number 5, when you create a table in Amazon DynamoDB, in addition to the table name, you must specify the dash of the table. A, global secondary index. B, local secondary index. C, sort key. D, primary key. Belinda says D. Justin says D. Sandra says D. Are you guys sure? Are you guys, don't you think it is A? Who agrees it's A? So nobody agrees it's A. Okay, so let's go with B and C. So number 6. Wait, are they not supposed to be 5? Why is it 6 now? Okay, so number 6, dash is up to 5 times faster than standard MySQL databases and 3 times faster than standard Postgres databases. A, Amazon Aurora. B, Amazon DynamoDB. C, Redshift. And D, Neptune. A, Justice is Aurora. A, Sharon. Alpha's Janai. Okay, wait, Clinton said B. Okay, but majority carries the vote, so let's go with A. Clinton, why? Why did you choose B? Can you tell us why? Did you see something else? Number 7, if you're developing an application that requires a database with extremely fast performance, fast scalability, and flexibility in the database schema, which database should you choose? I'm going to read that over again. I'm going to read it over again. If you're developing an application that requires a database with extremely fast performance, fast scalability, and flexibility in the database schema, which database should you choose? A, Redshift. B, Elasticache. C, RDS. D, DynamoDB. Leonard said A, but everyone else is saying D. I think I'm going to go with the majority. Let's see what is correct. Leonard, what happened? True or false? Number 8,
That was a
Amazon.
previous answer.
Oh, okay, my bad. Sorry.
Yes. Okay.
Okay, so number 8, true or false? Amazon Relational Database Service automatically patches the database software and backs up your database, storing the backups for a user-defined retention period and enabling point-in-time recovery. True or false? Sandra. Oh, look at my team members. They all say true. I believe them so much. I'm just going to select true. Oh. Okay, so 100%. Yeah. So that will be all. Amy, your answer came too late. Okay, so that will be all for today, I guess. So back to headquarters. Yeah, Belinda, you can clap now.
Joy, that's it for Team Air. We're done for today. if there's anything else to address.
I have a question, Sandra. Have you laughed this afternoon? I think I'm 10 years younger. I'm 80 years old now. Have you laughed?
Yeah, I have.
You know, I was to go for someone called Clinton. The way I kept on repeating, 3 times faster than Postgres, 5 times faster than SQL. And he was there saying DynamoDB. But I have left him for Frank. Eh? Now I have gotten my assistant trainers. Ah, very nice. Thank you, Sandra, for your team. Thank you, Fan. Thank you, Frank. And I know the other guys are going to be presenting on Friday. You guys have made us understand DynamoDB and Aurora. Clinton, mimi uko ukiimba Aurora, eh? But congratulations to you and your team, Sandra. We are looking forward for Friday. And Gail Annabelle is not looking forward to you guys knowing that they are presenting on Monday. She's very relaxed, very, very relaxed. Thank you, Sandra. Thank you to your team. Thank you, Belinda. Not Belinda. Belinda, come out of my mouth. Thank you, Sandra. Thank you, Fan. Thank you. Thank you, Fan. Thank you, Frank. Thank you, Sandra, once more. Gail. All right. Yes, Leonard is saying the session was very, very enjoyable. Key highlight. Can't see the screen, but I know people are laughing. Nice one, nice one. Yes. Frank, I think he should be training more. He should be given an opportunity. And Fan, you've been told that your voice is soothing. People. Imagine I've trained here for 2 months and no one has ever told me that my voice is soothing. I was only told it was froggy. Ay, my lord. Hey, dust. Dust is constant. But anyway, I was also told to dust off my theology certificate. I will do exactly that. How many ways can DynamoDB retrieve data from a DynamoDB table? Tunakwambia when we come for math. Justin, na alafu mniambie, how is it that you all got to be in one team? How is it that you guys got to be in one team? You know, it's very unfair. Eh? Ama masiko kwa group yenyu. The church will be in your group. I'm telling you, we are being shown dust. Now, guys, tomorrow, Chelsea, are you in class? Very nice. I agree with you, Patrick. The synergy in this group, it's amazing. And you guys, me, I've also learned something from this group, the same way I learned in the morning from Elfast. Now in this group, trust no one apart from either Fan or your group members. Hey, where? And the shots that have been fired this afternoon, I didn't even have enough, even a bigger helmet. Now, for tomorrow, we have Team Water. Let me just check here. In the morning, you see, I told you guys, be ready. We are going to be blown away. See what Team Air has done. Tumeachwa tukijipepea. We've been loving ourselves by Fan and Frank. Imagine. Hey, my lord. Now imagine tomorrow is what in the morning? Tomorrow we will be flooded by Team Water. They are coming with a tsunami. Team Water. Tomorrow is Team Water, and they'll be taking us through the AWS architecture. Kesho tunakunywa maji, sio uji. All right. So in the morning, anyone from Team Water? They are so still, like water.
Yes. Joy.
Yes.
We are here, man.
Very nice.
Tomorrow tuko na nyinyi, tumejitayarisha sana.
Very nice. Very nice.
We will be pouring content like crazy tomorrow.
Makofi. Hey, have you heard you people that they will be pouring and showering content on us? Makofi. Leonard, you're saying from fire to air. Joy Neminko. I've been told that I am a prophet. Wanamaji wanapita kesho. Wahewa na moto wamepita siku ya leo. And then in the afternoon, we are going to have safari. You guys, I think I should go get my brown or jungle green gear and a safari hat. And I need donations for a Land Cruiser. We are going on a safari in the afternoon. So after diving deep into AWS architecture, we'll take a safari to systems operations and CLI and tooling and automation, systems manager, and admin and development tools by Team Safari. Who was in Team Safari? Can I see you guys? Who is in Team Safari? Mark is saying, for those who've been seeing dust in their relationships, we got you covered tomorrow. Musembi, Makofi. Claps for Musembi. Tomorrow he will be cleaner than a new pin. What do we say about clean? You'll be washed clean. Who is in Team Safari? Anyone from Team Safari? Exactly, Leonard. Exactly. Anyone? Yeah. Ama watu wa safari walienda safari. This people of safari, did they go for a journey and they left us here? Tukawachwa kwa mataa. Mko na Land Cruiser? Team Safari, anyone? Anyone from Team Safari?
Bethany
Joy, we are
has
here.
Oh, you've lifted your
Tuko
hand.
class.
Poleni. Mi hata si ungeniambia Befalin. How are you, Befalin?
I'm good. How are you?
I'm fine, thank you. I have missed your soft voice. What do you have prepared for us? Mark has told us that in the morning they're going to wash us. And you guys, where are you taking us?
Adventure. Just be open to have a good adventure.
Very nice. Hey, my lord. Am I glad to have you guys? Thank you for that, Befal. I will come prepared. Where? Do you need snacks on the journey? I can come with a few.
Yes. You can support the whole class. Kila mtu akuwe na snacks.
but no
You need to
bananas,
watch
please.
it.
No bananas, please.
Hey, Leonard, umetoa emoji ya bananas wapi? Where? All right, tomorrow I'll come with. You guys were going to see monkeys and all in the CLI. So I will carry a few bananas. I cannot be shrubbing by myself here. You see, today even Fan helped me and she was happy. Thank you guys. Your presentation was amazing. Amazing. I am so happy. And I am just here praying that Esther will not be Hey, you even laughed, you fine. Oh, where you laughed? I'm praying that Esther is not here to see the potential people to take my job. You guys, you're doing good. You know, we might need more instructors. The way you guys, you're showing me dust over here, I might need to, the way I am dedusting my theology certificate after Arusi, I might need to dedust my CV once more. Congratulations, you guys. I am happy for you. So tomorrow, Team Water and Team Safari will be taking us on an adventure on a faraway island to someone who lives in a pineapple under the sea. Good evening, you guys. Bye bye.